Good morning. So here we are again, folks. Thankfully, just a couple of days. Today, what I'm going to go over is the Punnett squares, how to do them. I want to introduce you to the work that we would otherwise be doing here in class. Keep in mind, you folks also have a serial killer presentation in order to finish and get turned into me once we come back. So you get a couple of extra days. Fantastic. Monday, we'll have something really light so that you can have some extra time there to get it done. Normally, we were going to do that today, but I would really prefer to actually have folks here. Wow, I'm looking old, man. I did not sleep last night. All right, so let's get started. Now, the Punnett squares, you may remember, are really focused on trying to predict what the outcome of a genetic cross will be. What that means is what the offspring will have. What we want to do is we want to look at the alleles, the genes, the DNA that the parents have, and we want to try to predict what traits then the offspring will get from their parents. What is the likelihood that they'll get certain traits? This has been particularly useful throughout agriculture and things like that, where we want to breed plants that produce more food. We want to breed animals that produce more of whatever's useful. Wool for sheep, meat or milk for cows. Like all of that has been done, really trying to analyze what is the best crosses in order to produce the best animals. So let me get this up here. We're going to go kind of crazy for a moment. Whoa, the infinite tunnel of me. All right. So the idea is pretty straightforward. Yes, I know I'm presenting, or I chose to. All right, so when you take a look at this, right, what we're going to do is we're going to take the two alleles from dad, his letters, in this case, big B, little b. We're going to separate them on top of the Punnett square. There are two columns. One column here, you can see the dividing line that's vertical right there, and the other letter here. So one goes into each column. Pretty straightforward. Then we're going to take mom's alleles, her two letters, and we're going to separate them into the two rows. Once again, there is a dividing line going horizontally right across. So one goes on the top row, one goes on the bottom row. Now, once we have this, now we want to get all the possible combinations. To do that, we're going to take dad's alleles and we're going to copy them down in each of the column spaces below that letter. So capital B will get copied down into this square, and it will get copied down into that square. Little b will get copied down into this square and copied down into this square. So it should look like you see over here on the right. Then we're going to take mom's alleles and we're going to push them across in her rows. So capital B across the top two, little b across the bottom two. And when you combine that with the alleles that dad already put into these boxes, we now have all four combinations that these two parents can possibly produce. Capital B, little b, big B, little b, and little b, little b. Now, once that's done, all we need to do now is start taking a look and determining who will have what traits. If capital B is the dominant allele, and we know that's the dominant one because it is capital, for brown hair, we can now take a look at this and say, well, this child right here will have brown hair. This child will have brown hair. It's got a capital B. This one will have brown hair. It has a capital B. And this one won't. So, what percentage of the offspring will have brown hair? It's going to be 1, 2, 3 out of 4. Ta-da! We have predicted. If these two parents were real and they were looking at having a child, we can tell them now that 75%, 3 out of every 4 children should have brown hair. Remember, prediction. It doesn't tell us what the actual result is. It only lets us predict. Great. So then let's take a look at some examples. So dad has the alleles big B, little b. Mom has the allele big B, little b. All right, so we have both of their like genetic codes now. Capital B is dominant for dark skin, while little b is recessive for light skin. So when we take a look at this, we know that dad has dark skin. Why? He has a dominant allele for dark skin. We know that mom has dark skin. Why? She has a dominant allele for dark skin. If we were to set this up, we would take dad's two letters, got to turn on the laser pointer again, and we would take the big B and we would put it over here. Then we would take the little b and we would put that over here. Then for mom, we take her big B, put it right here. Her little b, put it right there. And believe it or not, this is the exact same Punnett square that we just did as an example. Push dad's alleles down, copy them into the columns below. Take mom's alleles, push them and copy them into the rows across. We would end up with the exact same combo. It would look just like this one. And so once again, now we know that 1, 2, 3 of their kids would have dark skin. 1 out of every 4 should have light skin. And we have our probability. Now, if you look inside our Schoology, and I'll start from the beginning instead of jumping right to it, here is Friday, 1/7, the 7th of January. It is our virtual Friday. And we've got the slideshow here. This has some practice. The rules of Punnett squares can be very useful to you in order to remember this, just because I created another document where it goes over and shows you how to do each one of these on a single page. So feel free to use that if you need it. What I have for us today that I'd like people to work on. Now, there's something about this that should also be relatively easy. If you have Cami, you right-click it. You're going to need to get it first. So first you're going to need to like download it with this button over here. It'll download over here in the corner. Now I always choose show in folder because that'll pop right up. It should be the top thing. And once you have it here, it gets more complicated because now in order to really activate it, you need to take it all the way over into your Google Drive, and then you can open it. It's challenging. You might have Cami connected on here, and in which case then you can open it with Cami across this bar. Here's the other option, though. I don't want us to do this whole thing, right? We're not going to do both pages. I want you guys to work on numbers 1, 2, and 3. Only numbers 1, 2, and 3. You can write those down on a sheet of paper. Write down 3 boxes that look kind of like this for number 1. Label it with a number 1 next to it. Put the alleles from one parent and then the other parent on the top and on the side. Complete the Punnett square. Move on to the next one. It should be very straightforward, very easy. For those of you who have already done it, this stuff is absolute cakewalk. And then we will worry about turning it into me when I see you next week. Now, if you do open this on Cami and you want to just complete it then, no problem. I got you covered. Because also inside this folder is the turn-in link that you can use if you just want to complete it in Cami, save a copy, and then upload it to me. It'll look something like this. And then you will click, upload your file, send it to me, and I take care of the rest. So I will leave it up to you guys. We are working once again on just numbers 1, 2, and 3 of this Punnett Square worksheet. So I hope this helps. Let me turn off the presentation. And we will be back again on Monday, just like this. Please do not fall behind. I know, well, number one, I know there's 2 of you that are probably going to watch this in the first place. So I'm mostly just wasting my time. But for those of you that are, thank you. Keep up with the work. It will pay off. I promise you we'll do this again on Monday. And I'll see you guys hopefully all in person on Tuesday. I hope you have a great day, or as good as you can. And yeah, I'll see you then.